Finally, 2.2.4, greatest integer function. I'll just draw something, then I'll erase it. So let's say we have negative 2, negative 1, 0, 1, 2. What we want to do is find the greatest integer just less than the x coordinate we're given. Well, less than or equal to. That's pretty important word. Less than or equal to. So let's take the number 1/2. 1/2 falls here, right? What is the greatest integer just less than or equal to 1/2? That just means the next lowest integer. So the next lowest integer from 1/2 is 0. So if we have 1/2 as our x, using the greatest integer function, our y will be 0. Okay, so what if we have 1? What if our integer is 1? Or our x is 1? You want the greatest integer just less than or equal to 1. Well, 1 is an integer. So our y is 1. So for every integer you have in your x column, that is what goes in your y column. So negative 2 is an integer, negative 1 is an integer, so is 0, so is 2. Okay, so all of the integers just fill in both spaces. However, what if you have negative 3/2? Negative 3/2 is negative 1.5. Negative 1.5 is here. What is the greatest integer just less than negative 1.5? That would be negative 2. How about negative 1/2? Negative 1/2 is here. What is the greatest integer just less than negative 1/2? That would be negative 1. Okay, so what about 3/2? 3/2 is the same thing as 1.5. What is the greatest integer just less than 1.5? That would be 1. How about 5/2? 5/2 is the same thing as 2.5. What's the greatest integer just less than 2.5? That would be 2. So what if we had something between these? Something like, here's 1/2. What if we chose 3/4? If we have 3/4, what's the greatest integer just less than or equal to 3/4? That's also 0, right? So if we had a 3/4 in here, we also get 0. But what if we had a 1/4? That's still going to be 0. So 1/4 would also give us 0. What exactly does that look like? So let's plot what we do have. Negative 2, negative 2, negative 1.5, negative 2. But what happens when we get to negative 1? It's at negative 1. At negative 1/2, it's negative 1. Interesting. When we get to 0, we have 0. I want to go ahead and plot all those other points. 1/4 is 0. 1/2 is 0. 3/4 is 0. But what happens when we get to 1? It jumps up to 1. So what this does is it creates a step. Once it gets to 1, it jumps up to this point. It includes all of these, but it jumps. When it gets to 2, it jumps up to here. Creates a step, jumps up to here. Creates a step, jumps up to here. Sometimes people call this the step function. So the greatest integer function actually looks just like this. These are closed in. And the left side is closed, the right side is open. So it looks something. something like that. This is your greatest integer function. So how do we determine the domain and the range of this greatest integer function? Well, the domain is actually going to be all real numbers. It's all real numbers because your x's go both directions. And it actually does include every one of them. Let's just start at 0. 0 to 1, 1's up here. 1 to 2, 2's up here. 2 to 3, 3's up here. So it includes every single number. It just jumps up in steps. The range is what's a little bit freaky. You would think that it's all real numbers. However, it only includes the numbers at these lines. It doesn't include all of those little fractions between the numbers. So how do you say the range for the greatest integer function? The range is simply the set of integers. The set of integers looks like that. It's a z with 2 legs in the middle. Or you can just say the set of integers. So how about if you change up the function just a little bit? Here we have the greatest integer of x minus 2. Okay, let's see how this is going to work. We might need a number line. Let's get this on here. So if we put 0 in here for x, 0 minus 2. 0 minus 2 is negative 2. Negative 2 is an integer, so we keep it. Okay, so what if we put in there 1/2? 1/2 minus 2 is going to be negative 1.5. Negative 1.5 is here. What's the greatest integer just less than or equal to negative 1.5? It's going to be negative 2. Okay? So put in a 1. 1 minus 2. 1 minus 2 is negative 1. Negative 1 is an integer. How about 3/2 minus 2? 3/2 minus 2 is negative 1/2. That's here. The greatest integer just less than that is negative 1. How about 2? 2 minus 2 is 0. 0 is an integer. How about 5/2? 5/2 is the same thing as 2.5. 2.5 minus 2 is 1/2. The greatest integer just less than 1/2 is 0. How about 3? 3 minus 2 is 1. 1 is an integer. How about 7/2? That's the same thing as 3.5 minus 2, so 1.5. 1.5 is here. What's the greatest integer just less than that? That would be 1. Okay, how about 4? 4 minus 2 is 2, and 2 is an integer. How about 9/2? 9/2 is the same thing as 4.5. 4.5 minus 2 is 2.5. What's the greatest integer just less than 2.5? That's going to be 2. And now 5. 5 minus 2 is 3, and 3 is an integer. So let's plot those. We have 0, negative 2. We have 1/2, negative 2. Then when we get to 1, it jumps up to negative 1. 3/2, negative 1. Then when we get to 2, it jumps up to 0. And then 2.5, 0. Do you see what's happening with this one? So it's solid, open. Solid, open. Solid, open. It's continuing just like on the previous page. So what is the domain and range? Well, be really careful with this one because they've limited the domain. So we know right now that the domain goes from 0 to 5, which means my graph is actually incorrect because it doesn't include anything less than 0. This little dot is the very end of my graph. So this is actually all of my graph. And the range is simply the set that includes -2, -1, 0, 1, 2, and 3. You can see that here, -2, -1, 0, 1, 2, and 3. Now we have the domain and range for a limited domain greatest integer function. So what does this one look like? The more you do, the easier it gets, right? Okay, so if we put 0 here, we have 0 plus 2, which is 2. That is an integer. I want to go ahead and take care of all the integers. We have 1 plus 2, which is 3. 2 plus 2, which is 4. 3 plus 2, which is 5. 4 plus 2, and 5 plus 2. Okay, now we have put a 1/2 in here. So we have 1/2 plus 2, that's 2.5. What's the greatest integer just less than 2.5? It's going to be 2. What is 3/2 plus 2? 3/2 is the same as 1.5. 1.5 plus 2 is 3.5. The greatest integer just less than 3.5 is 3. 5/2 plus 2, that's 2.5 plus 2, or 4.5. The greatest integer just less than 4.5 is 4. 7/2 is 3.5. 3.5 plus 2 is 5.5. The greatest integer just less than 5.5 is 5. 9/2 is 4.5, and 4.5 plus 2 is 6.5. And the greatest integer just less than 6.5 is 6. Now this function is not limited in the domain, so we need to plot the entire function. So we have 0, we have 0, 2, that's the beginning this time. We have 1/2, 2, then we have 1, 3. So just based on that first little step, we know what this function is going to look like. Closed, open, closed, open, closed, open, closed, open, just like that. What's the domain of this function? And what's the range? All the integers.